Good morning, good afternoon, good evening, and welcome to another episode of the OpenShift Container Storage Office Hours here on OpenShift TV. I am Chris Short, executive producer of OpenShift TV and host of the show. I'm joined by the one and only Chris Blum. I said it right this time. Hey, I can't be taught. So thank you for joining us today. We're going to be talking about a little bit of the future, right? So like this isn't released yet. This is something that is, to be released once it's done kind of deal. So I have to put that future disclaimer out there. It's not an official product or thing yet. But I'll let Chris explain because he's the one with all the knowledge about it.
Yeah, so exactly. I'm part of the data services BU, and obviously we're working on all the new stuff. We demo it as well, and we also have a UAT team, user acceptance team. So we get hands-on on the new stuff before it's released to qualify it for our customers. And today I just want to give you a sneak peek at what's coming very soon and what I'm working on, and have that as a little bonus for all those people that participated in our little quiz last time.
Oh, nice. Awesome. Yeah, that quiz last time was pretty fun. I was telling people that I'm so good at storage that even though I saw it beforehand, I still got third place.
Yeah, and it's a good sign because it means that you've participated in all our shows, or almost all our shows, and you've learned a lot of things on the way.
No, I'm picking things up.
And
I'm not the village storage idiot. Yeah, that I used to be. I kind of have some knowledge now, which is good. So we're doing something right here, it feels like.
Yeah,
awesome.
So I brought one thing to the show here. We call it the sizer, or the OCS sizing tool. I'm just working on that, and this will be available to you soon. And what we intend to use this for is this is a website running in your browser, just regular browser, and we use this to get the feedback from people that want to build an OCS cluster. And I've talked with a couple of our people in the field that have constant interaction with their customers and collected, hey, what do you usually get from your customers as a requirement? And what do customers usually ask you to provide in terms of sizing, or what are they interested in? And so what I got is my customers usually tell me about what kind of usable capacity they need. So the total capacity that you will get with the OCS cluster. And then the customer needs to know, okay, how do I need to size this OCS installation so that I hit that capacity? And so we built this tool mostly around this. So you have as little input as possible to get your desired cluster sizing. And working this is not fully finished yet. We still have to go through a little more testing, but this will probably come out very soon in the next year. We will have different platforms here. So you see we have AWS, GCP, Azure, and then VMs and VMware or IHV and OpenStack. So Chris Short would be somewhere in that category, your cluster.
Yes. Or the bare metal category. You can kind of go either way. Depends how you want to consider things.
So when you go with VMs or bare metal, you can set your CPU unit count, your memory that's available on the instance. And depending on that, we know how many disks we can put on the host. So let's say we increase the cluster capacity, and you see that over here, things change. And this is our output. So each box represents one node or instance or VM in this case. And this number tells you how many OSDs are in that node. And then we talk about how large is the instance and how much of that resource are we using for OCS services on here. So right now, to reach 20 terabytes, we need 3 VMs. And these 3 VMs would each have 6 OSDs on them, so 6 disks. And they would consume 20 CPU units and 50 gigs of RAM. So if you have VMs with 48 CPU units and 128 gigs of RAM, you would now know that there's enough resources available on those nodes that you can theoretically have other workloads on there as well. Or you can go ahead and tune this deployment a little bit. So like, let's say I really want 20 terabytes and I see that I still have some spare CPU here. So I could decrease it, either put it to 32 CPU units. Nothing changes except that we're not wasting as much CPU anymore. And I could decrease that to 64 gigs. And you see this changes what I changed on the left. Now, if I decrease the CPU units even further, 16, we see that this fills up 16 CPU units, but we need more VMs in that case if we go down to 16 CPU units per VM.
So I'm looking at it, and this might be a bug that you're aware of. The RAM utilization across that top row. Every time you changed it, it was like, you know, a round number on the first node and fractions on the next two. And I'm curious why that is.
So that's a good question. And to dig down into that, we can look at the advanced output here.
Okay.
So this is a picture. We can download this, but to understand how this algorithm allocates resources on the nodes, we can click on there, and then we see a little bit deeper into the algorithm that allocates the resources. So we're always talking about node sets. So node set is a set of 3 nodes. And then we have our OCS services, the pods, so to speak, that we need to allocate to those instances. And you see that the first node set, 3 nodes, first node, all CPUs are used, 40 out of 64 gigs of memory used, and we have 4 disks. And we do have services on this node. So we have the monitor, we have the MDS, we have Nuba, pods, and then our 4 OSDs. Second node, manager, monitor, Rados gateway, Nuba pods. Third node, manager, monitor, Rados gateway, MDS. And no Nuba here. And all of these 3 nodes have 4 OSDs. So you see that even though they all have 4 OSDs, they do have different, what I call the base services of OCS. So these do not provide capacity to the cluster, but they provide functionality. Like the MDS provides the CFFS part, the Rados gateway provides the object part.
Yeah, so people are asking, where can I see this tool? And I'm like, hey, no, by the way, it's from the future. We're still working on it. It's work in progress. But thank you for running through that there. JP Date asks, will this thing test the storage for speed, latency, and optimize it for OCP potentially? Is that part of the scope of this sizing tool or not?
So the sizing tool is just for the theoretical part. It will give you a glance of how your cluster might look like if you deploy it this way. We can't promise that the base services will exactly land like this, but it's like a theoretical assumption of how this will land.
Right.
And it's rather likely that they will distribute somewhat like that. So maybe not your first node, maybe that won't be 40 gigs, but maybe the second node will have 40 gigs, and then the first node will have 30. Maybe it's somehow distributed a little different, but pretty much the same way.
Cool. So what
Yeah, and then
would
you
what would be
click
like
on
more
this
some?
button.
Yeah, there you go. Yeah, show us more.
Sorry. Yeah, you can click on this button and this will download a picture of this down here. So you can put it into your presentation slide when you want to present what you're going to build.
Makes sense. The the SKU information button. What does that do? Does it just tell you what
Uh,
you're
yeah,
buying, kind of
so
thing, or
we're Red Hat, right?
right?
And we always sell subscription.
Right.
And we do have different subscription levels. We have standard subscription level, we have premium subscription level. So when you now want to build that OCS cluster, you need to know how many of our SKU items you need to purchase to support this cluster. So for 20 terabyte cluster um, with yeah, 6 nodes, and this computes to a total of 60 CPU units here. We know that or 60 CPU units that are used, but for this queue, we need to calculate with the available CPU units on a node. And we end up with, you need 48 SKUs, either the standard version or the premium version.
Okay, interesting. Do the SKUs change at all based on the platform setup? I don't think so, right? Or do they?
No,
No.
the
Okay.
SKU, the number of SKUs is only changing based on how large my cluster is. So if I shrink it down, now we are down to 3 nodes. And so we have 48 CPU units in total. And then we actually qualify for the starter pack. Or if I increase it and we go up to 9 nodes, like this, for 50 terabytes usable, now we need 72 SKUs.
Okay. Interesting. Very nice. I'm tinkering with it on my box here, just kind of playing with different things, VMs and VMware kind of deal, seeing if I can find anything. So each node, I mean, it has great detail here. I really appreciate that.
Yeah, so the SKU information is mostly interesting for our Red Hat folks. So
Thank you.
this will usually not be too interesting for a customer.
No.
But the good thing about the tool is you set a size like this, and then you want to share this with someone. You can go up to the URL, and then you can send that URL to someone, and it includes exactly what you said. And then the other person opens the link, and he will immediately see what you've been seeing.
Oh, JP Dade wants the SKU numbers for pricing. Okay.
Yeah, maybe I need to increase the size.
Font size, yeah. I'm going to drop them in chat for you. But yeah, those are the 2 SKUs for everybody interested.
And yeah, as we've seen before, if your cluster is small enough, you qualify for the starter pack. That's if you have 48 CPU units. If it's larger, then it's the standard SKUs. Also, what's quite interesting is if you select a public cloud, for example, GCP, we do always have instance sizes. Like for AWS, using local NVMEs, we recommend using i3EN 2XL. For AWS, we recommend the N5 nodes. For GCP, it's E2 standard 16. And then you see how your input vanished for the CPU units and the memory, because we don't need it. We already know that for the instance sizes in GCP. So we reduce the mental overhead, and now you only have the disk size. So the disk sizes that you will attach to the instances in GCP, and your usable capacity that you have in the cluster. And now in your cluster view here down, you see the instance sizes on the left here.
Handy. what has been some of the feedback you've gotten while you were building this, right? Like what led you to here, right? Is what I'm curious about.
Yeah, so a lot actually. So, but Chris, one note, and um, the SKUs that you put into the chat, this is for the starter pack. So use 181 or 182 if you have a larger cluster than 48 CPU units.
Yeah, got it. Let me put a big old cluster size in here and I'll get the right.
Yeah, so regarding feedback, I got a lot of feedback because I've been working this all over the month, and we've included a bunch of things over that time. We collected a lot of feedback, as I said, from the field. What kind of feedback did we get? Like what you see up here, we have what I call the support exception banner. And this will appear when you select a configuration that is not yet fully supported. We do have a couple of these newer platforms we have already tested thoroughly, but we haven't tested it enough to say, okay, we fully support that, no questions asked. And that's the case for GCP, for example. And or if you go on bare metal, and now the banner is gone, right? So bare metal is regularly supported, but now if I increase the disk size beyond 4 terabytes, you will see the banner appear, because right now we only support up to 4 terabytes. And if you want to go beyond, then talk to us. We want to understand why, and we want to vet that this actually makes sense. And this will not necessarily, this will change over time, obviously, but for right now, it's our support matrix, and this is built into the tools. It warns you, hey, be careful, you're leaving.
Realms of supportable configs. Yeah. That's cool. So there's a question in chat. Does OCS have any specific requirement for hardware disk? So, in my experience, spinning disk, not so great, but what is the hardware spec for the disks? I'm assuming SSD or better,
for
NVMe,
OCS, we only support flash disks. So.
Okay.
Yeah,
makes sense.
So SSDs or NVMe's would work.
Yeah. So you wouldn't.
For the public clouds, we've seen.
Go ahead.
Sorry, Chris. For a public cloud, you wouldn't want to put it on sometimes on the regular default storage. That's sometimes too slow. We do have recommendations for these public clouds as well. So yeah.
Where can I find those? Is the question. I'll dig up a link at some point. So follow up, could OCS use mixed hardware, maybe SSD and HDD together? Again, the support is only for flash based. So in theory, potentially, but NVMe is supported. Yes, it is supported, JP Dade, sorry. Back to Inception X's question, though, could it use mixed hardware? Remember, it's only supported on Flash, so that configuration would be an unsupported configuration, even though it might theoretically work.
Yeah, we're looking into mixed media. What you could theoretically do is SSD and NVMe. This will be something we will support very soon, and then you can select, hey, do you want to have it on the fast or the very fast disk? And you will have different storage classes for these different disks then. I think we also skipped a question or two. Does the restores already include OCP basic workload? It does not, because it's the OCS sizing tool. So right now, this is just for the resources that OCS will consume. And then you can either think about, okay, do I have enough space on these instances to run it on the side? And OCP itself usually uses very little resources. So one CPU unit, 1 gig of RAM across 3 instances. That's usually plenty to run the regular OCP workloads.
Awesome. Narendev is here. Hello, Narendev. Welcome. Let's see. Yeah, I did miss that question. Thank you for covering that for me. A lot coming at me this morning real fast. Sorry. Yeah, so Inception X says it's more clear now. Thank you. So can you get anything else out of this tool? Have we shown everything about it? I just want to make sure we've covered everything, right? Like,
I think that's mostly it. Interesting piece is that you get the instance sizes with the tool that we recommend on the different platforms. And the other thing is that it tells you when you do go out of the regular supported path, and you get the CPU unit explanations here. And the other thing is, if you open the tool for the very first time, and you know this from other websites, right? It will give you a tour of this tool and will explain to you, okay, this is why you do this is why you do that, and the whole thing, right? So.
All right. Can OCS do co-locate with OCP together? Because we have a few customers who are looking at HCI OpenShift three node compact clusters. So can OCS do that? Yeah.
Yeah, OCS can do that if you have enough resources.
Right.
Speaking of a very small cluster, three instances, is possible with OCS. And then, as you see, OCS consumes like the very minimum that we currently support is 10 CPU units per node, so 30 CPU units in total for the bare minimum. And then you can size your instances according to that.
Nice. Cool. All right, I'm trying to find the question for the Java memory heap size for our friend in chat there. As always, we answer all questions, no matter related or not. So let's
at least we try.
We try, yeah. So yeah, someone in chat asked, why is there a difference in memory for each node on that screen? 40, 39.5, 37.5. That's the same question I did.
Yeah, please scroll back to when Chris asked that question.
Yeah. No, but it's dividing by 3 essentially, right? And just laying out the 3 digits that are most roundest, I guess, right? What is your algorithm for math on that one?
So we have different pods that have different pod limits, and they're different, right? And we need to allocate these pods in our theoretical cluster to the nodes that we plan. And so when we then fit those pods onto the nodes, we get an uneven distribution of resources that we would need to run this cluster. And that's just what you're seeing.
Yeah, so you're seeing the pods getting distributed kind of as they would land, right? So the resource requirements, right? Like those are the requirements, not necessarily what you would actually end up with, right? So you would need that much, RAM to run that quote, configuration that you just put in.
And then the difference of what the node has and what you're seeing on the sizing tool is what you have available for other workloads.
Okay, so this is a good question from Sachin. Is adding new nodes cluster scale out possible with your tool? Now that would be a good question, right? Like I've already got this thing, like I have a known state of config, and then I need to add on to it. That would be like V2 of your product thing there.
Well, I can show the tool again.
Yeah. Because I mean, this is like I imagine this like somebody has an OCP or an OCS layout already, and if they're trying to add additional storage, they might want to understand what changes or what gets added.
Exactly. So let's say you're on, I don't know. Yeah, let's say with Azure, we're still there.
Mm-hmm.
So you started out with your minimal cluster, and you have your 3 instances of OCS. And now you're running out of space because you only have 2 terabytes capacity. So what you would do is you would go back to here. You would see exactly your deployment. And then you would say, okay, I need more space. And then as you drag the slider to the right, you will see, okay, your 3 instances are still large enough. You can add OSDs. So now I'm at 11 terabytes. Started with 2, now I'm at 11. All I need to do is add 2 disks to all of our instances. So my cluster looks like this.
Mm-hmm.
So as I drag the slider further, I'll see, okay, 4 is the max of what I can put on the instances because I'm running out of CPU units. So those instance sizes in Azure, I think they only have, they have 16 CPU units. And now they're exhausted. We don't have any CPU left. So we need to add new instances down here. So like if I want to jump from 2 to 18 terabytes, I need to add 3 instances and extend my cluster so that it looks like this, basically.
Awesome. So again, the three node cluster setup is possible. Someone's asking. I'm sorry, I can't. Manakatan, I think I said that right. Probably didn't. Do we need to add OCS scale out nodes plus 3 worker nodes at a time? It depends on your configuration, right? So you need to have the capacity to maintain whatever you need. So you can build a 3 node OCP cluster with OCS on it if it has enough resources. We discussed that previously. If you're adding more nodes, do you need 3 worker nodes at a time? If you already have the 3 and adding more is just adding more, right, Chris?
I think what you might mean is that do you need to add 3 OCS workers every time you want to scale out?
Mm-hmm.
Like, can you
Yeah,
add
that
only
makes sense.
one OCS node at a time? And theoretically, you can.
Yeah.
But as you know, that we're using replica 3 usually, so that we can actually we compare your data across the replicas and we detect when there's a bit flip or anything weird going on with your data.
Right.
And we can only have that when you have replica 3, because we look at each replica, and if one's off, we know you're off. If we have replica 2, we don't know which one is right and which one is off.
Right.
So because we need replica 3, we need 3 instances across which we can replicate, because the instances can go off and we don't want to have the replicated data on the same instance. Furthermore, as you see, if I were to add only that one instance, we have one OSD here, that's an uneven balance. It's easier if we add 3 nodes.
Right. All right. Let's jump to the net. Let's just do this linearly because there's some follow-ups. But let's answer Ahmad's questions first. If I'm going to install MySQL on OCS, for example, or any database that uses replication for for those non-MySQL users out there, they do sync replication, and OCS does the same storage replication. So it's technically double replication. What is the recommended way to manage that, I guess, is what they're asking. Like,
Yeah, that's a good question. We do get that
Mhm.
every now and then. We also get that with other applications like Kafka. How do you say it? Um, when you're setting up a MySQL cluster, then what we see often is you have an active and a backup,
Mhm.
and the backup it does get a sync replica, but what we want to ensure is that at best both MySQL instances survive as long as possible, no matter what goes down. So
Right.
those instances, those 3 instances that store your data, are usually distributed among or over all availability zones. So you're going to AWS, you have 3 availability zones in your region, and each instance is in its own availability zone. The one availability zone goes down, you don't even notice that with your cluster. Everything stays up.
Mhm.
So theoretically, you could argue that you might not actually need a backup MySQL server.
Right.
Now, yeah.
But
Now with other tools, like with Kafka, we often see that people turn off the replication in Kafka, for example, because you
mhm.
don't need, as you said, you don't need a double replication.
Yeah, there is overhead to that, especially with Kafka. Cool. I think that covers that question. Anything else you wanted to add there, or you good?
No, I think I'm good,
Okay.
as long as there's no follow up.
Yeah. So there's follow up to previous. I want to know whether combining infra label and OCS worker label gives any advantages when doing OCS scale out / redundancy management if we have infra nodes for OCS only. It's a mouthful. So they have OCS workers and infra labels on those worker nodes, it sounds like. And it's OCS only for those infra nodes, it also sounds like. So
So what
what
we have
advantages does that
is,
give you is yeah, go ahead.
we do have a deployment node. We call it infra
Mhm.
node deployment, where you flag your nodes as infra nodes, and then you only pay those queues for OCS, and you don't, and those nodes don't count against your OpenShift nodes.
Right.
So if you mix OCS with the regular workloads, you need to pay OCS subscriptions
Mhm.
and OCP subscriptions, because you're running both on the same nodes.
Mhm.
If you dedicate those nodes as infra nodes to OCS, then we're saying, okay, it doesn't matter. You're obviously not running any workloads on these nodes, and those you don't need to pay OCP subscription fees for those nodes. And in certain deployments, that makes sense financially,
Yes.
because it's cheaper.
Yeah. Um okay, where are we? Yes. What is the max node count in internal OCS 4.5 deployment?
That's
Max node
a
count.
good
That
question.
is a good question.
Actually, let's click on that link here.
What is that link so I can drop it in chat? I gotta pop open your tool real quick and make a. There we go. I got it.
Just need to log in.
Yeah.
Yeah, so that link appears when you use the tool, and you select something that needs a support exception, and okay, I logged in. I can share the screen again.
There you
And this is an overview of what is supported in Red Hat OpenShift Container Storage, and as you can see, starting at OCS 4.4, we actually look at the maximum number that are supported by RHCS. So like the external version. So the short answer is it's the same number of nodes as the external deployment.
Right. So Red Hatter Matt asks, OCS in external mode is obviously not part of the great tool. Any plans to add this? How much do I need on my OCP? Okay, cool.
So I do get a lot of feedback like that.
Okay.
A lot of people want to have external mode in here and have a button for that.
You have
actually,
a button for that?
It wouldn't look too different. Like if we go to bare metal.
Okay.
This is pretty much similar to what your nodes would need to look like as the external OCS cluster. And then you will need a fixed amount. I don't remember what. I think it's in total 16 CPU units and a bunch of RAM. So not a lot in your OpenShift cluster, so that that connects to your external cluster. We plan to add that, but it's not there yet because we want to release this tool as quickly as possible, and then we'll make some updates to it.
Right.
What we're also planning to do is we'll add like a little a screen that you can pop out, and then you can tune your deployment. Like we know that with our current settings, the OSD limits are too low for NVMEs. So if you have NVMEs, we know that, hey, you can squeeze out a little bit more speed by increasing the CPU units. And I'll call it the booster button.
The turbo button. Remember the old turbo button on the PC cases back in the day?
Yeah. So we'll add something like that, so you can tune your deployment and press the turbo button, and then you get more speed. You actually use a lot more of your NVMEs. Or something we're also working on is have OCS have special deployment modes that will allow you to squeeze OCS into even tinier deployment sizes. So theoretically, you can toggle a button, and it will allow you to reduce the requirements for OCS even further, and thus have a very compact deployment size for Edge, for example.
Nice. Love our Edge deployments. Matt says thank you. And that's it for questions. So feel free to plug along here.
Nice.
Unless anyone's got anything
I think we got everything.
That's good. Okay.
There was something when clicked on Azure, I guess.
It was
the
memory separation
thing. All right. Yeah. So what I'm very excited about is the new OCS release that will come out very soon. So we're looking at something that will probably be available to you after the holidays, when everyone has time to refocus on their work and get started on new stuff. And why am I so excited about the new things? Is because this new version will completely focus on backup and recovery. So we've finally enabled, like I always keep saying that Ceph is a great storage system, and we have all those features. We've tuned Ceph and built up all this experience with Ceph in our OpenStack days and the deployment since. And now we got to teach OCS to use all these features. So now we finally been able to fully switch on the snapshots and do backup recovery.
Nice.
And as I said, we've been doing a lot of UAT work, so user acceptance testing. Is it easy enough for people to understand? Are the buttons at the right location? Is the workflow correct? So it's a little bit of UX design, but it's also about what do our customers want to do, and what can we do to make it easier for them? And I'm very happy with what my colleagues have already done, which is they produced a set of really cool demos for how you can use backup software with OCS to backup your applications in Kubernetes. And I've seen a preview, and they will be released in January. And that will be a lot of fun for you because it's super easy. It's all tightly integrated into OpenShift, as is OCS itself. Like OCS has its own dashboards, and you can set up your snapshots and your cloning directly in the OpenShift web UI. It's nothing like external you need to use the CLI, but you can use the CLI.
Right. Which is always handy, right? Like people have their preferences. Me, because I'm the storage village idiot, I have I like the console, so that's just me. So could you touch upon the encryption security areas in OCS? That's kind of a big setting, like topic. Hang on to that one for a second. Let's answer Ahmad's question first. Can you help me understand replication versus erasure coding? It is a bit confusing for me. I am not a storage expert, so that I think is, a good question to quickly answer.
Yeah.
And then we'll hit the encryption.
So in layman's terms, erasure coding, or what is replication? Replication is very easy. We get one bit in and we replicate that, and now we have multiple times the same bit and we store it into different places. So whenever we want to read that bit, we just go anywhere of these locations, and then we can read it. And if any one of those locations fails, we go to the other location and read it from there. Right? But it's always the same data that gets replicated, and it's the same data in all locations. And it's very easy to do. It's not computationally expensive to replicate that bit. And yeah, you can theoretically, when you replicate, you can take any disk, and the content there is what you can read out. Now with erasure coding, we do have an algorithm. It's a little bit like RAID 5, if you're familiar with that. So you have multiple disks in RAID 5, and you have a failure number of how many disks you can lose until you lose all the data. Because with the erasure coding, you have that that faction of data disks and replication disks. And with erasure coding, you can freely set how many data disks you have and how many like failure capacity you have with it. So you can say, I want 5 data disks that will give you capacity, and 2 redundancy. That means you can lose up to 2 disks of any of those disks. Right. But to do erasure coding, you take your data, you split it into chunks, and then you calculate based on an algorithm, and there are multiple algorithms. You have your redundancy bits, and now due to advanced math, if you lose one of your data disks and you take all data disks plus 1 redundancy, then you can recalculate that data of the lost data disk.
That'll make sense to me someday. I mean, it does make sense to me, like in a theoretical sense, but like I'm not sure how that applies physically. Like anyways, I'll figure that out at some point. Hopefully that answers Ahmad's question, though. Let's touch on Sachin's question about encryption and security.
Let me give it.
Okay,
you
got an example, yeah.
One little example. By the way, there's a really cool Wikipedia page with an animation of all this. But let's say you have a very easy math, like 5 + 2 = 7.
Mm-hmm.
And now you lose 2. So you have 5 + x = 7. And you know what x is because it's 2, right? It's very easy. You take the 5, you take the 7, and you can rearrange it, and you say, okay, 5 + what is 7, and you know 2. And that's a little bit like erasure coding.
Cool. Are you
but as you see, to set this up, 5 + 2 = 7, you have to calculate 7. And that's your replication thing.
Got it. Okay.
And so erasure coding takes a little bit of computational time to set up. So the writes are slower. But because you actually need to read from multiple locations, erasure coding can be quicker when reading data.
Right. Which, okay, that makes a lot of sense now. Okay, thank you for that. Ahmad says, so the sizer tool covers this, right?
No, the sizer tool does not explain erasure coding.
No, sorry. All right, so let's tackle Sachin's encryption and security capabilities in OCS, because I think that'll take a few minutes.
Yeah, that's a little bit unspecific.
Right, like
you want a security stamp or something.
Yeah, I mean, I'm trying to just pull up the pages really just to give it features. Let's see, security and encryption, OCS security and encryption.
While you're looking for this,
yeah,
just one more note on Matt's question. Internal OCS internal mode, we don't have erasure coding. External mode, you can theoretically do that, but internal mode doesn't have erasure coding.
Need to get Red Hat Container Storage 4.6. Depends on the environment, and let's see. Managing, replacing.
So what we're working on in regards of OCS security and encryption is we're working on in-flight encryption, and this is a pretty broad topic in OCP anyways. So we will also feature in-flight encryption with OCS, so that any data that travels inside of the OCP cluster will be encrypted and nobody can sniff it off.
Okay, that makes sense.
And yeah,
FIPS. Okay, standard. FIPS. Yeah. Encryption, FIPS standards, and all. So if you're running, you can run a OCP in FIPS mode. I know we can do that now, right? And yeah, it's always hard because I talk to the to PMs and everybody else. It's like, which release did that come in at? I think it was 4.5, 4.4, like full FIPS compliance. I forget which release that came out in though. So that includes the storage piece, I'm assuming, right? Like what?
Yeah. So if you have FIPS nodes, then you can run OCS on there without problem nowadays.
Right.
I think that came with 4.4.
I want to say 4.4, and then like was fully tuned out like in 4.5, right? Like I think Tech Preview was 4.4. Anyways, so yeah, if you're FIPS, if you enable FIPS mode for OCS, you can add OCP just fine, right? And you'll be FIPS compliant at all times. So you'll be good there, Manikatan. So don't worry about that one. I'm trying to figure out like, how do you do encryption of the disks in OCS?
That is something that for the internal mode we don't currently have, but we plan to do that very soon. Not with I don't think it comes with the next release, but it's gonna come soon.
Yeah,
I've seen it on the roadmap.
Some point in the future. Yeah.
So,
I wonder if we should
well, it's not like 2 or 3 years in the future, but like earlier than that. I've seen it on the roadmap.
I wonder if we should do an OCS roadmap show beginning of next year sometime, right? Like,
yeah, we could do that.
Yeah, that might be a good idea.
Yeah, encryption at rest. That is something we're working on. The encryption part is not actually the hard piece, because Linux comes with great stuff. Like I'm running Lux on my workstation here.
Yeah, same thing behind there. Yeah.
And that works very well. But the big question always is, where do you store the key? Obviously, for my workstation, the key is in my head, and then when I turn on the workstation every morning, I just put in the key. But for a cluster, it's not as easy. And then we need to put those keys somewhere. And the question is, do we put it in OpenShift? Do we put it in Ceph itself? So Ceph itself stores these keys for the different disks. And our very smart engineers are currently working on that.
Yeah, it's a layered problem.
Quite far.
Yeah. I'm trying to think of the thing just left my head, and the RenDev just dropped a link to some YouTube video. I'm assuming it's a recipe. I don't know. Yes, it is. Okay. How to cut a jackfruit, the simple method. Never even seen a jackfruit before. That's interesting. So Manikatan asked, the boot volume or root volume with the Lux key, is that possible? Could you just put it in the actual host OS part of the system, do Lux encryption like that potentially? I don't know.
I'll put the no. I read it the other way around. I read it that he wants to encrypt the boot or the root volume, and you can't encrypt the boot volume because the bootloaders currently don't support that. But the root volume, you can encrypt that with Lux. I think there's some limitation, but usually when you set up your install with Linux, the basic installers, you tick a checkbox and they know exactly how to configure the partitions. I mean, I'm a storage expert. That's what I do. I just use the basic partitioning in my Linux installs. But yeah, for the Lux keys, we wouldn't want to store it on the nodes itself, because theoretically the nodes can get stolen. And then you don't want to have the keys lying unencrypted next to the encrypted disk. That wouldn't be very secure.
Yeah, Manikatan clarified that he meant store the Lux key inside the OS boot or root directory, so it will boot without prompting the password. No, that's not a good security practice. Sadly, it's not as clear and cut and dry as that. No, it's a good question, right? Like, but when you think about it, it's like, oh yeah, the key is right there next to the disk that's encrypted. It's like locking your car and then just leaving the keys on the hood, right? Like, what good is that doing at that point?
But I love the interaction with the audience today.
Yes, we really appreciate everybody tuning in today. Yeah, these are great questions. So yeah, this is our last show of the year, and we will be back next year. Just to let everybody know, not this. Are we doing one on the 7th? I don't think so. Hang on, calendar. Come on. Where are you? There we are. No, yes, we are doing one on the 7th. Okay, cool. So first week of the new year, we'll be back. First full week of the new year, we'll be back. And feel free to, kick the tires on some OCP and OCS configurations and come back with your questions next year, because we'll be here ready for them for sure.
And I'm already curious what you did over the weekend with your cluster.
What I did? Well, what did I do over the weekend with my cluster? I didn't do anything because what happened last weekend? We were doing something. What did I do last weekend? I think I actually took a break last weekend, believe it or not. Oh no, it was the Kubernetes contributor like celebration. So that's what I was doing last weekend, and spending time with family and such, watching movies.
Yeah, that's good.
That holiday time of year. So yeah, no, my cluster sat there and did nothing this weekend. Hence why I turned it off on Tuesday, I think, because I was like, well, I need to rebuild this thing, which I know Chris is going to laugh at me for. So yeah, I kind of blew it up, and it's very loud. So I need to reconfigure the cluster itself to be a little bit quieter and not so power consuming. As my wife yelled at me for the power bill this month.
So the craziest thing that I've seen so far is there's actually a company that will that sells rack units that are not vertical but horizontal, and you put your servers into liquid oil, and
I've seen.
the
Oh
oil is
yeah. I've seen that. That is crazy.
so
But
that
cool.
you could do that,
I
like
could.
get an old freezer and then just put a lot of oil in there in your servers, but it's really messy if you need to
Need
swap
to
out
replace any
something.
parts. Yeah. You're kind of screwed. Yeah. No, I intentionally have two hot spares on the front of mine so that I can easily get to it. When are we going to get OpenShift on Raspberry Pi? Check out okd.io. That'll probably be your best bet there. But OKD, I don't know if it supports the Pi architecture. I forget. But yeah, OpenShift on a Raspberry Pi, I don't think is like a big goal of ours right now. But who knows? Sometime in the future, maybe the Raspberry Pi will be like, we can do that now. So, do your best with OKD. I'm sure somebody's done it, right? Because I know I've done Kubernetes clusters on Raspberry Pi 3s. Now that the 4s are out, who knows what people have done with OKD? There's a lot of RAM in those now. So yeah. No, we did not share the link to the Sizer tool because it is very much in beta, or I should say alpha, I guess, right, Chris?
I consider it better, but it's not.
Beta, okay.
It's not yet ready to be released to the big public. We will do another beta round until mid of January, and I assume that after that it will be ready for public use. And then we'll also add it to the documentation, and you have links in there, and we'll talk about it again in this show.
Mm-hmm. Yeah, well, there'll be plenty of content. Trust me. On a Raspberry Pi, that's a challenge with resource requirements today. Yes, Frank, correct. Narendev, yes, I know. I've seen that article. I also built one back in 2018, New Year's time-ish, 2017, 2018. So yeah, I've got to figure out what I'm going to do technical-wise, project-wise, in my time off in the coming weeks. So it's not going to be installing OKD and a bunch of Raspberry Pis. I know that. It's going to be optimized power consumption on my OCS cluster. So yeah. Awesome. Great show. Thank you everybody for tuning in. Chris, you got any parting words for
No,
us?
thanks for watching, and thanks for the feedback on the Sizer, and glad you're here. Hope you enjoy your holidays.
Yeah, stay safe out there, everybody. That's the biggest thing. Enjoy your holidays in the safest way possible. We wish you the best of luck in 2021. We wish us all the best of luck in 2021. And this year is almost over, thankfully. So thank you for tuning into the show today. We'll be back next year.
Bye-bye.